Hello everybody, my name is RJ. I'm making this video because it's kind of become knowledge on all the audio forums on Facebook that I kind of have a unique knowledge about RTR speakers in specific. They made a particular product called the DAC-1 subwoofer, and there's a lot of these in Ohio, there's a lot of these in Portland, Oregon, and it seems like there's a ton of them down in Florida. What's going on with these, I keep getting a lot of questions about them, and the common consensus is this. People are finding these things used on Craigslist, Facebook Marketplace, or Reverb, or what have you. They're reading reviews from the 1970s that say that they're the best thing since sliced bread, and people are buying them, they're bringing them to XYZ speaker rebuilding shop. They get them refoamed, they bring them back home, they plug them in, and they sound horrible. And what's going on is people are literally throwing them away. They're tearing the guts out of them, and they don't understand what's going on inside of them. People have just been sending me messages. I got a message from a guy the other day that tore one of the differential drives out of this, and he said, "What is this, RJ? This makes absolutely no sense to me." First of all, I know everybody's been asking for this for over a year, actually closer to a year and a half, and life really knocked me off my square for a second, so I want to apologize for that. But I'm actually going to show you why, conversely, this is actually the best subwoofer as far as passive subwoofers are concerned that was ever made. I'm going to show you exactly what you're doing wrong. I'm going to show you exactly how to set these up, and I'm going to show you how, if they are set up properly, you can effectively relocate the furniture in your living room. I'm not kidding, I've done it before. So, with that being said, with subwoofer technology today, it's incredibly easy to make something play very loud, with a ton of attack, and make it play very low and very accurate. If you look at this, for example, Legacy Audio makes this. This is the active driver inside of this. If you look at this thing, it has an aluminum cone. It has about a 35-pound magnet structure on the back of it. It has a high compliance, high excursion spider and rubber surround. It has two 300-watt, 3-inch voice coils in each one of these, and the lead wires are interwoven inside of the spider system. And it has a hole in the back of it with a specific, it's kind of like a Venturi port. I'm not going to get into how that all works, but it's designed specifically to cool the voice coils inside this. There's two of these inside of this. It's then pressure coupled to a high excursion earthquake passive radiator. There's also two of these inside of this. It's housed in a 14 by 14 by roughly 28 box, and it has a 1,000 watt Class D digital power amplifier on the back of it. So, in the 1970s, technology like this didn't exist. Technology like this existed. Now, this is just a standard stamp frame driver, and this is the only active woofer inside the DAC-1 subwoofer, by the way. So the question became, how do you take this 12-inch woofer with an 8-pound ceramic magnet, one 125-watt voice coil, with a foam surround and a really generic high compliant suspension, and make it do everything that this does? Well, RTR went to work on that problem in the 1970s, and this was the result of a 3-year R&D project, and this is called the DAC-1 subwoofer, and that stands for differential area coupler. So, with that being said, let's take one of these apart and kind of look at what's going on. I've got two of these sitting on the ground, and I have two of them upside down. So obviously they sit on this plate, and if I remove this plate, what you're going to find positioned directly in the center of this, without me knocking these things over that I'm going to use later as a demonstration piece, is the active woofer. And again, this is the active woofer that sits inside of this. It's positioned right here. Now, with that said as well, if I pop the panels off the sides of this, you're going to see two 15-inch passive radiators. Now, with that being said, we really need to take a minute and talk about passive radiators. For the guys that are asking exactly how this works, some of what I'm going to go over is kind of elementary, and I think that most people understand how passive radiators function, but I don't think that most people understand how they work. I've played with thousands of subwoofers over the years. I started selling home audio in the late 1990s, and I went all the way up to becoming a sound engineer, and I've ran sound at large arenas, so I've set up subwoofer systems all over the place. And I can tell you, before I decided to take one of these apart and reverse engineer it to answer everybody's questions about it, I can say that I knew how passives functioned, but I didn't know how they worked. So with that being said, we need to stop talking about this. I'm going to show everybody how passives worked, how passive radiators work, and then I'm going to show you exactly what RTR did differently inside of this box. So before we get into it though, I'm going to kind of tell you what's going on. Whenever a cycle is generated at the passive radiator's tuned frequency, that passive radiator, and this is true of any passive radiator loaded speaker in the world with the exception of this one, that passive radiator only captures half the energy of each sine wave. These are designed specifically to capture 100% of the energy of the frequency wave. So with that being said, if we come over here, this is a passive radiator loaded enclosure that RTR made in the 1970s called a 2F. These were actually my dad's. I grew up with these. Awesome speaker. You could get these at Highland Appliance back in the 70s for roughly $400 a piece. So if you look inside that, you'll see there's two active 10-inch drivers, and at the bottom there's one 12-inch passive radiator. This is the active 10-inch woofer. It has a 2-inch voice coil. It's an Alnico speaker, meaning it has an Alnico magnet on the back of it. That's why it can be so small, and a very lightweight cone. If you look, this is the passive radiator that's in it. So, and by the way, just for those that don't know, the active woofer is just like any other speaker. It has a cone, it has, I apologize, a positive and a negative terminal, and it has a magnet and a voice coil on the back of it. A passive radiator is nothing but the frame and the cone, and that's it. There's no motor structure on the back of it. Now, if you look at the passive radiator, you'll notice a few things. Number one, the cone on a passive radiator is always going to be heavier than the cone of that of the active woofer. They're doing that specifically for tuning purposes. If I turn this around, if you look inside here, you're actually going to see a steel plate that's mounted inside there. They're doing that for weight. Everybody knows that they're doing that for tuning purposes, but what most people don't realize, that by weighting them and mass loading them like this, that actually creates a crossover frequency point mechanically. So what we really need to talk about is exactly how these passive radiators react when they're inside of the cabinet in relationship to the active woofers, and what's going on with the pressure differential that's created inside the cabinet to make these things move back and forth. So with that being said, if I come over here, and I was half ready. All right, so now what we're going to do is we're going to look at passive radiators and what they actually do in relationship to the active driver. During this video, I need everybody to kind of keep in mind a couple things. I'm going to talk about the point of neutrality a lot. The point of neutrality is when the speaker's in its dead state. There's absolutely no power going in it. So what that means is the pressure inside of the cabinet is equivalent to the pressure that's outside of the cabinet. Okay? So if I turn this up, now one other thing, when most people demonstrate how passive radiators work, they start at a high frequency and they will actually lower the frequency of the active driver, so you can start to see the active woofer react to so you can see the passive radiator react to the active drivers. I think that's the wrong way to look at it, and based on what RTR did to engineer this cabinet, I know that they looked at it the other way as well. So we're actually going to start from the point of neutrality and we're going to move our way up in frequency, okay? So if I run this at a low enough frequency and you look at what's going on right here, you're going to see the active drivers move themselves in and out of the cabinet. Now, if you look at the passive radiator, at the exact same time that the active drivers move out of the cabinet, the passive radiators are moving into the cabinet. So the reason for that is because when the active woofers move away from the cabinet, what's actually happening is you're increasing the internal volume of the box. So if you increase the internal volume of the box, yet you don't induce more air into the cabinet, that's going to put it under a negative pressure, which is going to activate that passive radiator and pull it in. Now, conversely, the exact opposite thing is going to happen when the active drivers move into the box away from the point of neutrality. They're going to move into the box, and then that's going to decrease the internal volume of the cabinet, which is going to pressurize this cabinet, which is pushing the passive radiators out. So imagine for a second that this is a frequency wave that I made out of some crap that I found laying around somewhere. I don't even want to know what. And imagine that this is the point of neutrality. Now, if I put this right here, and this is our neutral point, and our active drivers are moving right here, once they get up to here, this is going to be the furthest point of excursion. So that means that your active drivers have moved out just like this. Now, once the driver board and the receiver reverses positions and the amplifier's transistors start to reverse, it's going to start to bring that woofer back into the cabinet. Once it gets right here, both speakers are going to be at their point of neutrality. So what you're seeing right now is you're watching these things go back and forth like this. All right? But once they get to this point, when they come back to their neutral point, absolutely no horsepower is being applied to the passive radiators from the active woofers. So I want everybody to understand exactly what's going on here. You have an active woofer that's moving up from its point of neutrality. It's reaching its maximum point of excursion. It's coming back to its point of neutrality. The amplifier is driving it into the cabinet. It reaches its maximum inwards point of excursion, and then it's coming up back up to its point of neutrality. But look at this. At the exact same time, you have a passive radiator that is doing the exact opposite thing at the exact same point in time. So what that means is when the active drivers are moving upwards, the passive radiators are getting sucked in or pulled into the cabinet. This is a process called cross-phasing, okay? But if you remember earlier, I said once the passive radiators are going to almost always be heavier than the active drivers. So if I take, and you can't see it right now, and I start to increase the frequency, Kevin, aim that at that speaker. I'm just going to go up. What's eventually going to happen here is because that woofer is so heavy, this is at 18 hertz, they're still out of phase with one another. Now I do know for a fact that the crossover point or the tuning point on this speaker is 45 hertz. So if I move this up, all of a sudden, boom, you can hear low frequency. And the higher I go, until I get to 45 hertz, you can actually start to hear that bass. So I'm going to get right up to 40 hertz. Now I can turn it up, and it's actually making some noise. So this is what I want everybody to understand. Because I turned that up, here's what just happened. Assuming that this is the active woofer and this is the passive radiator, and they've started 180 degrees out of phase. But what just wound up happening is we took and slowed that down another 180 degrees at 45 hertz. Now this is what's going on. Everything is in phase. And when this happens, it's like the wrath of God, especially with that speaker. Trust me, I used to listen to those growing up. It's incredible. This is the perfect world for a passive radiator. But note a couple things. If you look at these frequency waves, number one, note that the active woofer always starts a half a cycle starts a half a cycle before the passive radiator, and it always stops a half a cycle before the passive radiator. So when the speaker's at this point, this is what we have to really talk about so everybody understands what's going on. Well, first of all, let's everything that we're going to talk about from this point forward, because I'm only going to use one of these sine waves, so I don't have to, I don't have to hold them both up. Let's just assume that this is what's going on. Our active woofers and our passive radiators are now in phase, okay? So let me get rid of this, and I'm going to put this back right here. I'm going to move this out of the way over here because it's annoying me. So now that our passive radiators are in phase, that means that all of them are moving in and out of the cabinet at the exact same time. They're going like this. So again, they're in phase, but we need to talk about exactly what's happening. When that passive radiator and the active woofers are moving away from the cabinets and they get to this point, that speaker internally inside of the box is under its highest point of negative pressure, all right? When the amplifier's transistors reverse and go negative, which happens right here, by the way, it does not happen right here. The amplifier doesn't know where those speakers are at. It doesn't care. It just knows that the driver board's telling them to reverse bias and go negative. Now what happens is at this point, they start to go negative. So the speakers are starting to go back into the cabinet. So as you leave the point of neutrality and you come away from the box, the active woofers are applying horsepower to the passive radiators. All right? Now when they start to reverse and they start to go back into the box, remember the negative pressure that's been created inside of that box as a result of the excursion of the woofers pulls on all those woofers in every direction. So as you start to go back into the box, even though there's being power induced into that voice coil, the active woofers are really starting to let off the gas, because as they move in, they're no longer applying pressure to the passive radiators. The passive radiator at this point is in phase with that active driver. So as they come back in together and they reach their point of neutrality, at this point right here, there's no horsepower being applied. The net result, or I'm sorry, the net pressure inside of the cabinet when it reaches this point is zero. It's neutral. Nothing's going on. However, now the voice coils are going to start to drive the active woofers back into the cabinet. And remember, because that passive radiator is so heavy, its weight and momentum is going to keep it going into the cabinet, and it's going to keep it in phase with the active drivers. So now what's going on is the active drivers are starting to drive themselves into the cabinet. The passive radiators are doing the exact same thing. So all three of the transducers are pressurizing the cabinet. So as I go into the cabinet, or as we go into the cabinet, I should say, instead of pulling on the passive radiator, now the drivers are pushing on the passive radiators. At this point right here, once they reach this point, the amplifier's reverse positions, or its output transistors reverse positions, they start to go positive, and they're going to drive the woofers back out. Now, essentially, the same thing that happened right here to here is now going to happen from this point to this point. So, as the active drivers move back out towards their point of neutrality, once again, they're letting off the gas in relationship to the passive radiators until they get to this point right here. So, from this point to right here, we're letting off the gas. That the air pressure that's inside the cabinet is pulling equally on the active woofers and the passive radiators. So once we reach this point, once again, there's no horsepower being applied to the passive radiators from the active drivers. So that being said, every time those speakers move in and out, this point, this point, this point, this point, and this point, no power from the actives is being applied to the passives. So think of it like this. As you're leaving your point of neutrality, whether you're on the positive side of the sine wave or the negative side of the sine wave, you're applying gas to the passive radiators with the active drivers. When you're returning to the point of neutrality, whether it's right here to here or from this point to this point, you're letting off the gas until you have 0 horsepower being applied to those passive radiators. But what if you could shift that point of neutrality out of phase by 45 degrees on each half of the cycle and intercept that wave right here, right here, right here, and right here, instead of cutting it in half? So that's exactly what RTR figured out how to do with this speaker. So with that being said, there's 2 ways to effectively increase or decrease the excursion of a driver and the passive radiators, and this happens proportionally, by the way. You can either A, turn the volume up and increase the amplitude, or B, you can lower the frequency, because if you lower the frequency, that takes more excursion because that wave is longer, so obviously you have to move the speaker up and down or back and forth, or however you want to look at it, further to reproduce that wave. So once again, watch. I mean, as you can see, these things are moving, but I'm going to simply lower the frequency. I just lowered it to 33. I'm going to lower it more. I'm going down. Now, I'm not increasing the amplifier power at all. See what happens as I lower the frequency? You can see the speakers moving in and out further. It takes more power. But again, the biggest thing to note here is that the active drivers and the passive radiators excursion increases and decreases proportionally every single time. That's true of every passive radiator loaded cabinet in the entire world, with the exception of this. So with that being said, I'm going to show you right now what this does, because they figured out a way to defy every single law. Again, we have 2 15-inch passive radiators, and we have 1 active 12-inch woofer. So Kevin, if you want to bring that light over here. So let me Okay, so something that I want to make mention, and I'll bring this over here and do this like this. I'll move these spacer blocks. When we move to the crossover frequency point, meaning we're bringing these woofers back into phase, everybody needs to understand something. With a typical passive radiator loaded enclosure, it doesn't matter if I speed the frequency of the active driver up or I slow it down, okay? What's going to happen is whether it speeds up or slows down, the passive radiators are going to become out of phase with the active drivers. This is one of the problems that RTR corrected with this box. And as again, you can see when that happens, you get cross-phasing here, so you get cancellation here, you get cancellation here. Wherever you see these lines intersect, these woofers are going to cancel themselves out, all right? So with that being said, I'm going to show you what's going on here. I'm going to start at roughly 40 hertz. I am going to start higher this time. You can see that the 12 is just getting it on, slamming getting it on. But watch what happens as I lower the frequency. I'm at 32 hertz right now. I'm going down, down, try and get this at the same time. You're noticing that the passive radiators are starting to move. Boom. Watch what happens. I'm at 26 hertz. You can see that the excursion of the active driver is actually decreasing as the excursion of the passive increases. So that defies all the laws of the typical passive radiator loaded enclosure. But I'm going to continue to go down, down. I'm going down even more. Look at this, the active woofer, it's starting to stop. Now, if you look at this right now, it's kind of hard to see with the iPhone camera, but that active driver is moving about 1/8 of an inch, and these passive radiators are blinging. All right, so right now, you've got a 15-inch passive radiator right here, and you've got a 15-inch passive radiator on this side. The excursion on those passive radiators right now, my guess is roughly 1.5 inches, and if you look at the excursion of the active woofer that's making that happen, it's only moving back, I mean, maybe that far, maybe a 1/16 of an inch, maybe 1/8 at the most. Now, with that being said, the very first thing that I thought of when I saw this was the first law of thermodynamics. You cannot create nor can you destroy energy. You can either A, convert that energy from one form of energy to another, or B, you can transfer that energy from one place to another. The fact that the active woofer is hardly moving and the passive radiators are just slamming tells me that RTR figured out an incredibly effective way to transfer that energy from the active woofer into the passive radiators. A very effective way. But before we can even start talking about how it is that they do that, we need to talk about the incredible operating advantages that this active driver has. There's a set of parameters that are written for every woofer or low frequency transducer called TL and small parameters. Most of them the end user doesn't have to worry about, but there's a couple of them that you do have to think about. The first one is called Xmax. Xmax is a parameter that states how far the active woofer can move before the voice coil loses linearity with the magnetic field. So in other words, how far can that woofer move in and out before the voice coil starts to lose power simply because it's leaving the magnetic field. Now, this is a speaker that an idiot blew up. I'm not going to get into that. But if you look at this, I mean, this thing moves in and out, and you can see that it's literally starts to move away from that magnet. That happens very fast. If the woofer's not moving at all, what that means is you don't have to worry about Xmax anymore, because this voice coil is literally down inside of that magnet gap in its most efficient place 100% of the time. It's not moving. It's literally staying pressurized 100% all the time. That is incredibly efficient. Very efficient. Now, the second parameter, or the second thing that you have to worry about when you get into those ultra low frequency ranges is a parameter called X mechanical. X mechanical states how far the active woofer can move before it fails mechanically as a result of excursion. So whether the cone breaks, whether the voice coil former collapses on itself, whether the spider tears, I don't even care what it is. If it fails because of a result of excursion, you've exceeded X mechanical. Well, if the driver's not moving, you no longer have to worry about X mechanical. So that's another incredible advantage. The only thing at this point that you have to be concerned with are the thermal limits of this voice coil. And because it runs so efficiently at this low of a frequency, you shouldn't have to put a whole ton of power into it to make these things just sing. So as far as the active driver is concerned, that's really important. Now, before we go any further with this, we're going to take one of these apart. I'm going to show you how they work and what they're doing here. But I want everybody to understand there's 3 separate chambers inside of the speaker. And even though they work in unison with one another, they work completely independently of with one another. If any air leaks between these chambers or outside of the woofers whatsoever because they're not sealed properly, and I do mean any, this speaker will no longer work. There's differential drives in here that are pressure coupled to this transducer, and it's incredibly important that this works right or is sealed correctly. So if I come over here and I remove this, you're going to see the first chamber. This is a chamber obviously for the active woofer. If you look over here, you're going to see a 10-inch hole for a 10-inch transducer with a round plate. That's the back half of the differential drive. If you look over here, I've got this one taken out. You'll see the exact same thing. Now, obviously, if I pop the side panel off of this and I look down inside there, you're going to see this is where the 15-inch transducer goes. And then this is where the back half of the differential drive mounts into the speaker. And this is what you're going to pull out of there. This is what this looks like. So this is the DAC and the DAC-1, and again, that stands for differential area coupler. When I took this apart and I decided to reverse engineer it, now understand that no information exists on these anymore. I think Jim Wygand has the build sheets, but I don't think he has the engineering notes. I kind of had to figure out exactly what they were thinking here. When I first looked at this, and I'm actually going to use this one as a demonstration piece, and this is the same thing as this, it just doesn't have the gaskets or the foam surrounds on it. So I'm going to set that over there. When I first looked at this, I thought to myself, well, yeah, that makes sense. They're using the difference in area of this plate right here, coupled together with a mechanical tube, and the difference of area of this cone to create a pressure differential inside that chamber. So I thought, yeah, so the difference in area, and then this is the coupler. I'm really glad that I thought about that before I made this video, because once I started thinking about it in terms of the way an engineer thinks, I'm pretty sure I was dead wrong, but I'm going to explain that later. So we got to kind of talk about what this does for a second. You can imagine this obviously sits right in here just like this, and this one is just trashed. I mean, I got these from somebody that just didn't take care of them. Because this plate right here is mechanically coupled to this transducer, the first thing that tells you is that this has to move in unison with one another. That means this plate has to do the exact same thing that this cone's doing at the exact same point in time. Once I figured this out, I can tell you, I'm not going to do the math. There's a difference in area of 67 square inches between this inside plate and this outside plate. So if this thing sits in here and it's sealed properly as it's supposed to be sealed, when this moves outwards, what that does is it's going to create an a very negative pressure right here inside of this cabinet. So when it moves inwards, it's going to do the opposite thing. It's going to pressurize it. So once again, as we talked about over there, the surface area, the diaphragm with the largest surface area is going to win. So if we look at this, what's actually happening here is this. Let's assume for a second, again, this is our point of neutrality. Let's assume for a second that we're right here in the sine wave. However, as you could see, the active woofer wasn't moving at all. And the reason it wasn't moving is because it was prevented from doing so by the back half of the last wave to begin with, but I'm going to explain that in a second. So electrically, the amplifier is up here, all right? And that means that our DACs are all the way out. So what's now going on with our DACs all the way out and our speaker is at the point where it's pressurized the most outwards, at this point the amplifier is going to start to reverse, all right? Now because you have a very negative pressure right here, that also means you have a very negative pressure right here. That means that you have a very negative pressure on this side of this diaphragm, and you have a very negative pressure right here. So this creates a spring assist. And what they're doing is they're shifting the neutral point by doing that from right here to up here. So when this amplifier reverses right here, the negative pressure right here takes and it slams the back half of that differential drive into the wave. It slams it into the top of the wave. So they've shifted the neutral point from here to here. Now, the exact opposite thing happens once the speaker reverses position and it reaches right here. Now, at this point, just like any other passive radiator, loaded enclosure, the passives are going to be right here. But again, the active driver is still going to be right here because it never left that position to begin with. It's going to try to drive itself back into the box, but it can't because, again, they've taken and they've slammed the DAC into that wave. So that can't happen. So if you've shifted your neutral position from right here to right here, and from right here to right here, and from right here to right here, and right here to right here, check this out. Look at what happens. Think about this logically. What we've done is we've taken and we've moved this up here. There's our neutral position right here to right here. And I know this is kind of a crummy way to show it, but now look at what's happened. We've literally captured the entire frequency wave inside of the neutral point. So the center chamber never goes neutral, which means it's always charging those passive radiators. That's exactly why this happens. This is very, very efficient, and it's incredibly clever. So it was really kind of fun reverse engineering this. Now, with that being said, when you do that, because you've captured that wave, that's exactly why the speaker's not moving. If you've slammed your DAC into the wave right here, that means it's boom. The moment it tries to go neutral, remember the DAC is out here, but it's coming back in as this is trying to go reverse, but it can't because it's hit it right here. Once the active driver gets all the way down here, the DAC is going to be inwards all the way, and the exact opposite thing is going to happen. Now this chamber is going to be pressurized. This chamber is going to be positively pressurized. This chamber is going to be positively pressurized, and this chamber is going to be positively pressurized. So when that happens, instead of slamming it into the wave when it's right here, now those DACs are going to spring back, and they're going to pull on that wave right here. They're going to pull on it so hard that as it tries to move outwards, it can't happen. It flat can't happen because it's being pulled on by the DACs and by the pressure differential that's created on the outside two chambers. So that's how that works. Now, the problem with this, or what's going on, and as a matter of fact, I meant to take this out of here. This is a spare driver that was refoamed by XYZ Speaker Shop that goes inside of here. This will never work, ever. You can't tell probably in the video, but like if I look at this, the first thing that I notice is that I could see light through this foam. I can put this right up to my mouth and I can breathe through it. So what that means is that this isn't sealed. If air can leak in and out of here, you can obviously understand by the fact that this doesn't move and these passives just jump, that this is an incredibly high pressure situation. So what that means is this has to be sealed. The active driver has to be sealed. The DACs have to be sealed. It doesn't matter where they're leaking. If you have, if one of the DACs is sealed and one of the DACs isn't, well, now what's going to wind up happening is you're going to start seeing this stuff. I mean, if one's moving one way and one's not moving, boom, you got cancellation right here. If one of them's not sealed, I guarantee you, and one of them is, and I'm just using this as a hypothetical example, if one of them's sealed and one of them's not, now what's going to happen is that I guarantee you the one that's not sealed is going to load completely differently than the other one. I mean, you can start having stuff like this going on. It just doesn't matter. You're going to wind up with phasing problems all over the board. And that's going to cause these not to work. But again, just the foam surround problem with what people are putting on the active drivers is going to make it not work, because even if the DACs are properly rebuilt, which none of them are because they use the same exact style foam that I just showed you on that one that was rebuilt from that place in Ohio, they flat won't work because, again, they can't pressurize. And then the foam that's on the DACs, they again use the same foam. It's the same manufacturer, same brand. It fits very well. It fits perfectly, and that's why they put it on there. But people don't understand how this differential drive system works, and they don't understand how critical it is to make sure that these are sealed. So as these things just start jumping back and forth at that low frequency range, people don't get it because the passive radiators aren't moving. The reason the passive radiators aren't moving is because the cabinet's not sealed properly. And again, if the cabinet's not sealed properly, then boom, you can't make this work. It's not possible. So that's pretty much it for the DAC-1. I mean, if these are rebuilt right, again, you could see that these were just jumping. I don't care if you had Macintosh. I don't care if you had JBL. I don't care if you had Altec, Lansing, Infinity. I mean, I don't care whose subwoofer you had. Nobody's subwoofer did what this did. This thing plays dead flat from 16 hertz, from 150 hertz all the way down to 16 hertz. Now, earlier, when I told you that we were going to talk about why they call this the DAC-1, a couple things. If we're intercepting the wave right here, and we're keeping the back half of that differential drive pressed right against this wave, all the way from here to here, and so on and so forth, think about that. They've figured out a way to pneumatically couple that transducer directly to this frequency wave, instead of creating a situation where it simply reacts to it. And there's a huge difference, a huge difference. And again, it's very clever and it's very efficient. Now, here's the other thing that's incredibly important to understand about this cabinet. Because they've coupled it directly to that wave, when the 12-inch woofer moves, it doesn't matter if it's going forward or backwards. It doesn't matter if it's being raised in frequency or if the frequency is decreasing. What's actually happening is, because it's coupled to that wave, it stays in phase with the active driver the entire time. The entire time. So they've completely eliminated the phasing problems. Now, the only thing, now that of course happens after we've moved this over here like this. So I mean, we still have that half a cycle lag, but once it's reached this point, they start moving back and forth like this instead of going like this as the frequency changes, which eliminates all this cross-phasing crap. So this is an incredible product. RTR only made about 8,000 pairs of these before they got screwed royally by Circuit City and went bankrupt because they refused to pay for a mass order. If you have a set of these, they're truly a gem. If you have any questions about how to rebuild them, call me. I'll help you do it. I will tell you this. The foam that seems to work the best for these is the foam that's made specifically for the JL Audio, the original W6 series. It's sealed very well. If you use that, it fits very well. It's a tad bit small for the 15s, but I stretched it a little bit and it works really well. But if you use this and you seal it with a sealing compound that you can get anywhere, Mike DeZoo at Circuit Shop Audio sells it online. Simply Speakers, everybody sells it, the sealing compound. You paint the backs of these and make sure that they're sealed. At first, when I first looked at this, when I saw this this clear coat on the back of this, I thought to myself, man, that must be for damping. But I also found that the foam was painted over with a sticky substance, and that's kind of when it hit me. Well, that makes all the sense in the world. What they were doing, this has nothing to do with damping. They did this specifically because they didn't want any air leaking through this cone. Maintaining an absolute 100% airtight seal on these cabinets is critical to making this work. And nobody out there knows that because, again, there's no more information on this. Again, I think Jim in Sioux Falls has the cut sheets, but again, he doesn't have the engineering notes. But just looking at this and thinking about how it works, that's just the way that it has to be. And if you do that, I mean, this is the result. This is what happens. And this is happening on both sides. You have two 15-inch passive radiators that are doing that. And again, take one more look at this. That 12 doesn't even move. No other manufacturer did anything like this. So that right there is how you take this woofer and you make it do everything that a $4,500 Legacy Audio Foundation subwoofer does. So I hope you guys learned something. If anybody comes across something that's unique like this and you're not sure how it works and you want to learn, call me. You can send it to me. I'll tear it down just like I did to this one. Figure out how it works. We'll figure out what we got to do to make it work. You know, again, I like doing stuff like this. If you have any questions about this subwoofer whatsoever, inbox me. I'm going to do another video on the 280 DRs. A guy named, his last name I think is Curtis. His first name escapes me. He's been on my inbox about it. And again, I apologize I haven't gotten to it. I just had a lot going on recently. So again, let me know if you have any questions. This is an awesome speaker. God, do not throw these away just because you're not happy with them. I promise the only reason you're not happy with them is because they're not being rebuilt properly. These were $600 a piece in the 1970s. The other thing is RTR made every single component inside of the speaker. They had a pulping machine. They made the cones. The only thing that they didn't make are the frames. But I mean, they made the cones. They made the voice coils. They made the differential area pistons just out of a piece of Formica. I mean, they made everything in here. They even weighted it with a piece of wood that they cut out of a block. Everything was handmade right inside their factory. They made very nice stuff. And as you can see, I have a lot of it. So again, thanks for watching. Hope you learned something. Peace.